Yesterday we discussed about the electric charge and how the charge and all, and I given the basic history of the charge as well as to how to understand the concept of charge, how the charge can produce the electric field as well as magnetic field and both electromagnetic field. Someone is asked me that some students are expressing some doubts regarding that also. Simply you can understand, if there is no charge, there is no electric field. If there is no electric field, there is no magnetic field. And finally, both electric field and magnetic field both are available when the charged particle is accelerating. That is the main criteria here. So now there are two types of charges are there. One is called, there are two types of charges are there. One is called the positive charge, other one is called the negative charge. You may get the doubt, sir, you compare the electric field, electric charges as well as the masses. That means mass is all times positive, while the electric charge may be positive or may be negative. So you simply take charge is analogous to mass. Charge is analogous to mass. Now, unit of charge. SI unit of charge is called the coulomb. 1 coulomb is equal to 3 into 10 to the power of 9 stacked coulombs. Do you understand this is? SI unit of charge is coulomb. 1 coulomb is equal to 3 into 10 to the power of 9 stacked coulombs. So, charge of electron, not only the charge of electron, even though for the proton also, if you are going to speak about in case of electron, this value is minus 1.6 into 10 to the power of minus 19 coulombs. 1 coulomb of 1 electron of charge is equal to minus 1.6 into 10 to the power of minus 19 coulombs. Is the charge of electron. 1 coulomb. Now we are going to discuss about 1 coulomb of charge consists of how many number of electrons. In that case, supposed to be, in that case, 1 electron of charge is equal to 1.6 into 10 to the power of minus 19 coulombs only magnitude. That is, 1 electron consists of 1.6 into 10 to the power of minus 19 coulombs of charge. So 1 coulomb is equal to, it is multiplied with the same. If it is in multiplication, it comes to this side, it becomes division. 1 coulomb is equal to 1 by 1.6 into 10 to the power of minus 19 electrons. That value is equal to 0.625 into 10 to the power of minus 10 to the power of 19 electrons. That is 6.25 into 10 to the power of 18 number of electrons is available in 1 coulomb of charge. Now 1 coulomb of charge consists of 6.25 into 10 to the power of 18 number of electrons. So 1 coulomb of charge consists of 6.25 into 10 to the power of 18 number of electrons. This is the basic thing. So it is very useful in solving the problems. Now, now we are going to discuss about the basic properties of the charges. In the basic properties of the charges, look at here. The first basic property of the charge is additivity of the charges. Additivity of the charges in the sense charges are adding. In the sense charges all times follows the simple algebra. Supposed to, if there is a one system is there, that rather than that one, I'll explain with one another example. That example is sodium. Atomic number of sodium is 11. It means that it consists of 11 number of electrons and 11 number of protons. So 11 negatives and 11 positives, total charge of the sodium in atomic level is equal to 0. So you are adding positive and negatives. Similarly, one another example. There is a one person is there. He is carrying a bag. In that bag, 3 different kinds of spheres are there. One is red sphere, blue sphere, and the violet sphere. The red sphere of mass is equal to 2 kg, Blue color sphere is mass is 3 kg and violet color mass is equal to 5 kg. What is the mass of the bag? So, is a bag is a system. That bag consists of 3 different spheres. The mass of the all spheres is nothing but the mass of the bag. Alright, that means 2 plus 3 plus 5 is equal to 10 kg is the mass of the sphere. It is the mass of the sphere, correct? Like the same, supposed to be there is a one system, it consists of n number of charges. I am labeling that n number of charges Q1, Q2, Q3 and so on Qn. If I am going to speak about the total charge of the system, let it be capital Q, then charges are the scalars like the masses which you did in case of the bag. So that's why Q is equal to Q1 plus Q2 plus Q3 plus Q4 plus and so on Qn. Suppose it is easy to understand this is the total charge of the system. But as of our discussion, charge may be positive or may be negative. So I will tell you with one other example to understand what is the nature of additivity. In this, there is one system. A system consists of 4 different charges. Plus 1, plus 2, minus 3, plus 4 are the 4 different charges. As of our discussion, total charge of this system is assumed to be capital Q. As of this, algebraic sum of these 4 charges is nothing but the charge of the system. That is 1 plus 2 minus 3 plus 4. You are going to get the charge of the system is equal to plus 4 coulombs. So means this simply follows the simple algebra. The physical quantity which follows the simple algebra, that is called the scalar like the masses. So this is about additivity of the charge. Next property of the charge. Next property of the charge is conserved. Conserved in the sense, see, charge neither be created nor destroyed. Means charge you can't create and at the same time charge you can't destroy. So for to understand this one, I am using the chemistry here to explain that. There is a one sodium and it is combined with the chlorine. It is an atomic state. This one oxidation number is 0. Even for the chlorine atomic state is 0. These two are combined to form the sodium chloride. So 2 molecules of sodium chloride. The sodium of atomic number is plus 1. Chlorine of atomic number is minus 1. 2 into plus 1, 2 into minus 1. Why? Because 2 molecules are there. 2 into plus 1, 2 into minus 1. Total is equal to 0. It means before charge is 0, even after chemical reaction is also charge 0. That means charge neither be created nor destroyed. Charge neither be created nor destroyed. That is the law of conservation of charge. Next thing is charge is quantized. Charge is quantized in the sense you can understand. I constructed a building. If I look at the building, there is a one structure is there. If I get into the structure, first I have to see the rooms. Rooms are made up with the walls. Walls is made up with the cement and bricks. That means the building blocks of the building is nothing but the bricks. Okay, so like how many bricks you used in the sense, maybe you may see that 10,000, 20,000, 30,000 of bricks. You can't say that there is a 30.5, 30.25 bricks like that. You are telling all times integral multiples. Like here also one brick is there. That brick is called the electron. So you are expressing the charge of the system, or charge is always transferred as an integral multiples of charge of an electron. This is the best example to understand that. Sodium atomic number is 11. It loses one electron, it becoming into Na plus. Plus 1 in the sense it loses one electron. Minus 1 in the sense it gain one electron. You can't say it gain half electron, it lose 3/4 of electron. all times you are telling that it lost one electron, it gained one electron. Magnesium is there. Magnesium plus 2 you are writing. Mg plus 2. That means 2 electrons it lost. Zinc is there. Zinc plus 2. That means 2 electrons it lost. All times you are expressing the charge integral multiples of charge of an electron. The charge of an electron is the basic charge. That basic charge is E. It's maybe like plus 2, plus 2, plus 3, plus 4, plus 6 also. It depends on the type of molecule which you are going, but you are expressing in the integral multiples of electron only. That is where this is called the law. This is called the charge is quantized. Charge quantization in the sense all times you are expressing in terms of the electrons only. That is Q is equal to Ne. That is called the quantization of the charge. Next is charge is invariant. Charge is invariant. Invariant means no change. Charge is invariant. When the charge is invariant, if I am going to speak about the charge is invariant in the sense, supposed to be there is a, still now we discussed about charges are at rest, they are creating the electric field, so that we are going to speak about those things. So there is Q1, Q2, there is a one charge, Q1 is equal to positive charge, Q2 is equal to negative charge. So unlike poles, unlike charges attract each other. So that means Q1, Q2 is equal to, Q1 is negative, positive, Q2 is negative. So total it is a negative value is less than 0. So Q1, Q2 is less than 0. It is speaking about attractive force. If Q1, Q2 speaking greater than 0, the repulsive force. Repulsive. So this is due to light, this is due to repulsive. This is unlike, this is like charges. So this is the description about the basic properties of charges. One is positive and negative, both are attract each other. That attractive force you can show with Q1, Q2 is equal to positive charge into negative charge is less than, again negative charge is less than 0. Attractive force in the sense we are represent Q1, Q2 is less than 0. Repulsive forces in the sense both charges may be positive or may be negative. That is Q1, Q2 greater than 0 is nothing but repulsive force. This is about the basic properties of the charges. So if you are going to speak about the basic properties of the charges, first basic property is additive in nature. That is Q is equal to Q1 plus Q2 plus Q3 and so on Qn. Second thing is conservation. Charge can neither be created nor destroyed. Third one is quantization. Q is equal to, charge is nothing but integral multiples of the charge of an electron. Q is equal to Ne. Next thing, charge is nothing but invariant. Means even though the charge is in the motion, there is no change in its magnitude. Next thing is, like poles, like charges will be repel, unlike charges will be attract. For the attractive force, Q1, Q2 less than 0. For repulsive force, Q1 Q2 greater than 0. This is the basic properties of charges.